Many people find the 4 operations with fractions one of the trickiest topics to get their head around. So if you're struggling, stick around to watch this video. I'm going to do a whistle-stop tour of all 4 operations, adding, subtracting, multiplying, and dividing fractions. This will be on a non-calculator paper, so I would really advise you try to do all of this without a calculator. I'm going to jump straight into the video, so if you need a little bit longer to read through the task board, then pause the video now and hit play when you're ready. The first thing you need to be aware of is when adding and subtracting fractions, we must have a common denominator, and I want to share a visual with you that helps to illustrate why. Because some people would make the mistake of simply looking at our 2 fractions in our calculation, so we've got 1/3 plus 3/4 in this case, and then simply adding the tops and adding the bottoms. And when that happens, it shows that we haven't fully understood what a fraction actually represents. If you look at the visual, I've got 1/3 shaded in pink. So you can see 3/3 make a whole one, but I'm only interested in one of those thirds because there's 1/3 in my question. And then I've got 4/4 below representing a whole one, but I've only shaded in 3 of those because I only want 3 of the quarters. And then I've put sevenths underneath. And so if you've taken the numbers in the calculation, I'm going to write this in red just so you know this is incorrect. And you've looked at this and you think 1 plus 3 is 4 and 3 plus 4 is 7. That doesn't work. If you look at my illustration of sevenths below, and I've purposefully shaded in 4 of those sevenths, hopefully you can see that 4 sevenths on its own is smaller than 3/4. So we can't be adding 2 things together and getting less. That's not going to work in this case. So that tells me something's wrong. We can't do that. And that's where the common denominator comes in. We find a common denominator by finding the lowest common multiple of the denominators in the question. And remember, the denominators are the bottom numbers of your fraction. So in this case, the 3 and the 4. And we'll talk more about actually doing that in some example pairs in a moment. But what I want you to see from this visual is if I find a common denominator, so in this case we'd be looking at twelfths, we can express our quarters as twelfths because 3/4 is the same as 9/12. And we can also express our third in twelfths because 1/3 is the same as 4/12. So we can create 2 equivalent fractions with the same denominator and then we'll be able to combine them together. We can't combine things that have got a different denominator because they're not of the same measure or the same unit. It won't work. And so we look at finding a common denominator. And ultimately what we'll be trying to create is when we add our 1/3 to our 3/4, we'll be able to tell how many twelfths that is equivalent to. And I'll break this down in the next part. So here we've got 3 questions. Notice the first one already has the same denominator. This would be considered a much easier question because you've not got to find the common denominator. We can only add and subtract fractions with the same denominator. Now these are already in ninths. So if I've got 1/9 and I add 4 more ninths to that, altogether I have 5/9. So it's as simple as add the top numbers, and once you've got a common denominator, that bottom number stays the same. The problem comes when we haven't got the same denominator. We have to make one. So notice in my setup here, I'm giving myself space to rewrite each fraction. There's 2 fractions in my question. My working out will require 2 fractions. I'm going to rewrite each one. I need to find the lowest common multiple of 3 and 12. So I could begin by listing multiples of 3. I'm going to do this at the top. 3, 6, 9, 12, 15. And multiples of 12, 12, 24, 36, and so on. And what you will see is 12 is in both lists. Now, if you're not super confident with multiples and finding the lowest common multiple, I do have a video on that, so you can go and watch that first if you feel like that would be helpful to you. So I can see here that the lowest common multiple is 12. That means I'm going to rewrite each number in my calculation in twelfths. 2/3, I want to know how many twelfths that's equal to. Well, we're going to ask ourselves how many 3s go into 12. That would be 4. I've timesed it by 4. And to keep it equivalent, whatever I do to the bottom, I also do to the top. So 2 times 4 is 8. So 2/3, if I wanted to represent it in twelfths, would be 8/12. Now, luckily for us, our second fraction is already in twelfths. So I keep that the same. That's still 5/12, that's not changed. And so that's my working out. That's my middle step, if you like. And then, as with the question above, now I can write my answer. Because I've got a common denominator, now I can write down what the answer is. Remember, that denominator stays the same, and we just add the tops. So 8 plus 5 is 13. Now, if you've watched my lesson or you're comfortable with mixed numbers, you might want to convert this to a mixed number answer. I'm just going to do it at the top because I've run out of space, but you'd do it next to. If I wanted to convert this to a mixed number, I would ask myself how many 12s go into 13. That would be a whole one with 1 left over because 12 needs 1 more to get to 13. So 13 over 12 is absolutely correct. It's mathematically accurate, the value is right, but it's not the simplest way we can write it. It's not the neatest and tidiest at the end. So we could also write that as a mixed number, 1 and 1/12. And I'll leave it up to you for today how you want to leave your answers. You can leave them as improper fractions or you can leave them as mixed numbers. But when you get to the point of sitting your exams, it's good practice to be able to write them as mixed numbers. For our third question, again, we've not got a common denominator, so I'm going to have to make one. In the previous example, 12 was a multiple of 3, so we only had to change one of our fractions. That's not going to work with this one. We're going to need the lowest common multiple of 5 and 2, and this is going to require us changing both fractions. So if I list my 2 times table, 2, 4, 6, 8, 10, 12, and my 5 times table, 5, 10, 15, and so on, we can see that 10 is the lowest common multiple. And you might be able to see those without having to list the multiples. But if you struggle, listing the multiples is absolutely fine, and you'd be more than welcome to do that in your exam. How many 5s go into 10 is 2. And so we do the same to the top. 4 times 2 is 8. And how many 2s go into 10 is 5. Remember, we're rewriting each fraction now in tenths. So I've rewritten the first fraction as 8/10, and now I'm rewriting the second fraction. 1 multiplied by the 5 is 5. And now because our denominator is the same, I can simply add the tops. That's completely coincidental that it's the same as the previous question. So that's another 13. And if we want to write it as a mixed number, 10s into 13 go once. I can only fit 1 whole 10 into 13, and I will have 3 left over. Here are 3 questions for you to have a go at, and they are in a similar style where the first one already has a common denominator, so you will be able to go straight to answer. The second one, you will need to find a common denominator, but you will only need to change one fraction. And the third one, you will need to find a common denominator and you will have to change both fractions. So I'll be going straight through the answers, so pause the video so you've got time to do these and then hit play when you're ready to see the solutions. So with our first one, we've already got the common denominator 8, and if we add the numbers on the top, we get 5/8. With our second one, if you listed the multiples, or you might have just been able to spot it, our lowest common multiple of 5 and 15 is 15 itself, which means that second fraction is going to stay the same. I don't need to change it. The first fraction, however, I'm asking myself how many 5s go into 15? That was 3, and so I need to times the top number by 3. 3 times 3 is 9, which means altogether I've got 16 over 15. And if you wanted to convert that back to a mixed number, 1/15 goes into 16 with 1 left over, and that denominator stays the same. And with your final question, the lowest common multiple of 6 and 9 is 18. 6 goes into 18 3 times, and so 1 times 3 is 3. 9 goes into 18 twice, and 4 times 2 is 8. 3 plus 8 is 11 over 18, and there's no way for me to simplify that, and I can't convert it to a mixed number. Subtraction works in exactly the same way as addition. So we still need a common denominator. We've already got a common denominator of 7, and this time we've got 6/7 take away 4/7. Well, if I had 6 of something, in this case 7ths, and I take away 4 of those, I've got 2 left. So the answer to this one is 2/7. In your second question, we need our common denominator, and just like before, and you might be able to spot these quicker if you're confident with your times tables, in this second question, we need a common denominator, and hopefully what you can see either by looking or by listing multiples is that the lowest common multiple of these is 20, because 4 will go into 20. 4, 8, 12, 16, 20. So I'm going to be using the lowest common multiple or lowest common denominator of 20, which means our second fraction isn't going to change. It's already in 20ths, we can keep it as it is. 4s into 20 go 5 times, and 3 times 5, because we do the same to the top as we did to the bottom, is 15. The denominator is now the same, so it will stay the same, and if I've got 15 20ths and I take away 3 of those 20ths, I'll be left with 12 20ths, which doesn't need to be converted to a mixed number, but we can simplify it because both of these numbers are divisible by 2, but they're also both divisible by 4. So we always try to divide by as much as possible, and you can do that in small steps if you need to, or one big jump. If you're not confident with simplifying fractions, I also have a video on that, which I'll link above. So if I divide 12 by 4, I get 3, and if I divide 20 by 4, I get 5. As with before, if you want to leave your answers today unsimplified, just whilst you get used to this method, that's fine. So you could leave your answer as 20 over 12, but by the time you come to sitting your exams, you will need to be confident in simplifying as well, because the final answer here would be 3/5. And once more, we need to find a lowest common denominator, and if you needed to this time, we could list the multiples of 8 and 5. So 8, 16, 24, 32, 40. Now I know that 40 is in the 5 times table, so I don't need to go any further. But if you weren't too confident, you could also list your multiples of 5, and you will find that 40 is the first one you reach. So we're using 40 as our common denominator. We've times the 8 by 5, so 5 times 5 is 25, and we've times the 5 by 8, and 2 times 8 is 16. 25 take away 16 is 9, and our denominator stays the same, and that one doesn't simplify. Once again, here are 3 questions for you to have a go at. Similar layout again. So the first one, you already have the common denominator. The second one, you need to find the common denominator, but only one fraction will change. And in your third one, you'll need to find a common denominator, but both fractions will change. So pause the video so you've got plenty of time to do these, and hit play when you're ready. For our first one, 9 take away 3 is 6, and we've already got the common denominator of 11. For the second one, our lowest common multiple was 18, which means our second fraction can stay the same. 6 goes into 18 3 times, so we would multiply 5 by 3, which is 15. 15 take away 7 is 8, and the denominator stays the same. And if you did simplify this one, which at this stage I said was optional, so I don't mind if you've not, if you did simplify it, that's 4 over 9. For your third question, the lowest common denominator is 70. We've multiplied the 7 by 10 to get 70, and so 6 times 10 is 60. And we've multiplied the 10 by 7 to get 70, and 1 times 7 is 7, which gives us 53 over 70. Now that's really the tricky part out of the way. Most people find addition and subtraction trickier because there's more steps. Multiplication is your easy one. So we're going to start by looking at multiplying by just an integer or whole number. Now what you've got to think of when you've got the whole number 5, that's the same as writing 5 over 1. 5 divided by 1 is just 5. So we don't bother to put over 1 on a fraction because it's just the whole number itself. And then we multiply tops and multiply bottoms. So 5 times 2 is 10 and 1 times 3 is 3. A mistake people tend to make when they've only got a whole number is multiplying the top and the bottom. So they'd say 5 times 2 is 10 and 5 times 3 is 15. But the reason that's wrong is because if you then simplified this fraction, we can divide both of them by 5, we would get back to the 2/3 at the start, which is wrong. It shouldn't be 2/3 because it should be the equivalent to 5 lots of 2/3. So we don't do that. So we only times the integer or whole number by the top number, the numerator. Now we could express this fraction as a mixed number, and again I would say that's optional for today, but you will need to understand how to do it by the time you sit your exams. 3's into 10 go 3 times, that would be 9, so there's 1 left over to get to 10. Denominator stays the same. And this method just carries on. When you've got two fractions you're multiplying together, it's as simple as times the tops, 1 times 1 is 1, and times the bottoms. 4 times 5 is 20. And once more, times the tops, 5 times 2 is 10, and times the bottoms, 8 times 9 is 72. And here's a case where we can simplify. They're both divisible by 2. 10 divided by 2 is 5. 72 divided by 2 is 36. Here are 3 very similar questions for you to have a go at. I'm going to go straight through the answers, so pause the video and hit play when you're ready to see the solutions. For your first one, remembering that we only times the 4 by the top number, giving us 12. 4 times 3 is 12. And it's 1 times 10, which is 10. Which first of all we can simplify. That would become 6/5. Remember, this stage is optional. If you got 12 out of 10, that's great. And then 5's into 6 go 1, with 1 left over. With this second one, 1 times 1 is 1, and 6 times 3 is 18. Nice and straightforward on that one. And your last one, 4 times 4 is 16, 7 times 11 is 77, which can't be simplified. And your last set of questions here today. Just a reminder that this is the same as 6 over 1. And when we divide fractions, we have to find what we call the reciprocal of the second one, which just means flip it upside down. So we would rewrite this question as 6 over 1 times by 3 over 2. Because there isn't a straightforward method for dividing fractions, we have to manipulate the question a little bit. So in order to make it a multiplication, which we know how to do, we did that on the previous slide, in order to force this divide to become a times, we have to flip this second fraction upside down. And then it's as simple as we did on the last slide. 6 times 3 is 18, 1 times 2 is 2. And we can simplify this. In fact, this one will get us a whole number because 18 divided by 2 is 9. For our next one, just a reminder that that whole number 5 is the same as 5 over 1. So if we rewrite this question, first fraction stays the same, it becomes a times, and we flip this second one upside down, so it becomes 1 over 5. 5 times 1 is 5. 6 times 5 is 30. And this one can also be simplified. They're both divisible by 5. 5 divided by 5 is 1. 30 divided by 5 is 6. So it equals 1/6. And one more. We're keeping the first fraction the same. It becomes a times, and we flip that second fraction upside down. 7 4s are 28, 9 3s are 27, and so if we want to, we can make this a mixed number. 27 goes in to 28 once, with 1 left over. Last set for you to have a go at. Remember to rewrite those questions as multiplications, and it's always useful to give yourself the setup before you start manipulating the numbers so you guide yourself through the question and you know where you're going. Once more, pause the video so you've got time to do these and hit play when you're ready to see the solutions. Remembering that this is the same as 7 over 1, that first fraction stays the same. We flip the second one upside down. So we've got 7 fives is 35, 1 times 4 is 4. And if you did choose to write that as a mixed number, 4s into 35 go 8 times, that would be 32, with 3 left over. For this second question, we've got the first fraction stays the same. Remembering that this is the same as 3 over 1, flipping that upside down gets 1 over 3. 2 times 1 is 2, 7 times 3 is 21, and 2 over 21 can't be simplified. And your last one, the first fraction staying the same, we're making it a multiplication. Flipping that second fraction upside down gets us 8 over 6, which simplifies to 4 over 3, which can then be simplified into a mixed number as 1 and 1/3. Well done if you got through all 12 of those questions. We're now going to have a go at some multiple choice. I will pop a 30-second timer on the screen, so you will have time to jot things down if you need to help you work these out. I would not recommend you trying to do it all in your head. So here's your first question. Work out 5/6 plus 10/24. And the correct answer for that one was D. Here is your next one. 9/10 subtract 1/8. Here are your options. The answer for that one was C. Multiplication next. 12, that's the whole number 12, times 2 over 7. Here are your options. If you said C, that would be correct. And then if you wrote it as a mixed number, that would have been D. So either of those answers are correct. Let's do 3/4 divided by 5/9. See if you can remember the method for this one. Here are your options. If you said A for this one, that would be correct. And if you converted it to a mixed number, then B was correct. So you can have either of those two answers. Well done. The last part of our session today then, here is some independent practice for you. So grab something to write with and on and have a go at these 10 questions. You've got a complete mixture of all of the things we've looked at, from the very easiest to the hardest, and I will leave it up to you if you decide to simplify any of your answers or convert them to mixed numbers. I will put the answers on in their non-simplified version and their simplified version, so it doesn't matter and you'll be able to check them all. I'll pop these answers up in just a second, so for one last time, pause the video, have a go at those questions, and then hit play when you're ready to see the answers. And here are those answers. So take your time, go through and check you've got those correct. If you need to go back and watch any of the examples again, then please do. Sometimes it can just help to see them once more. And if you feel like you have a specific question or something you're not quite understanding, feel free to post it in the comments below. We do try to answer all questions related to the content of the video. And with that, all that remains to be said is a big well done for taking part in this video lesson today. The more revision that you choose to do in any format, whatever you decide works for you, will benefit you greatly when you come to sit your GCSEs, particularly with a subject like maths. The more you put in, the more you will get out. Remember to subscribe for more videos like this, and so that you can continue to find us if you need any help and support. All of our resources on YouTube, TikTok and Instagram are and will continue to be accessible to everyone for free. I'm Charlotte, thank you for watching this video. I'll see you in another one soon.